thank you to the Scientific and Medical Network and to the Institute of Noetic Sciences, which have supported me and my work. I've had the sort of encouragement of both of these organizations practically since the first publication of my book in 1981. And I'm immensely grateful for that because, as David mentioned, there's been quite a lot of hostility, many attacks, but it's been enormously reassuring and, in fact, essential to feel that I have friends as well. And the two organizations that have been the rocks on which I've been able to rest and build foundations are the Institute of Genetic Sciences and the Scientific and Medical Network. So it's very appropriate that this event is hosted by both of them. Well, first of all, I want to say something about what the idea of morphic resonance is, for those of you who are not familiar with it. So just a very brief summary. Um, it's basically the idea there's a memory inherent in nature. The so-called laws of nature are more like habits. Each species has a kind of collective memory. Giraffes, hedgehogs, hummingbirds, each hummingbird species, each species of plant, foxgloves, um, roses, each species has a collective memory, and then each variety within the species has a kind of collective memory as well. And each individual contributes to that collective memory and draws upon it. So the idea of the collective unconscious of Jung is just the human aspect of this much more general hypothesis of collective memory. And perhaps the most radical aspect of this hypothesis, and certainly one of the most controversial, is the idea that our own memories don't depend, as usually assumed, on stored memory traces inside our brains, but rather depend on morphic resonance from our past. The idea of morphic resonance is essentially based on similarity. Similar patterns of vibratory activity in self-organizing systems influence subsequent similar systems across space and time. Resonance works on the basis of similarity. It's an automatic similarity selection system. So what I'm suggesting is that morphic resonance works from the past to the present across space and time. I'm not saying it works independently of space and time, because that would mean it worked from the future as well as the past. I think there are influences from the future, but they're much rarer than those from the past. And morphic resonance is a hypothesis about a memory principle in nature. So it's from the past, but it's across space and time. And because we are most similar to ourselves in the past, that's why we resonate specifically with ourselves in the past more than any other human or any other organism. And that's the basis, I suggest, of our memory. Well, that's a very brief, in a nutshell, summary of this hypothesis. I first thought of this idea, at least in outline, in 1973. I was a fellow of Clare College, Cambridge. I was also a research fellow of the Royal Society. And I was working on the development of plants. How do plants form their leaves, their flowers, their stems, their roots? I was working on the hormone auxin, indole acetic acid, and I discovered that auxin, this hormone, is made by dying cells. It's a breakdown product of tryptophan, which is one of the amino acids in proteins. And when cells die, the proteins are hydrolyzed, they're broken down, and then the amino acids released by the hydrolysis of proteins are further broken down, and one of the byproducts of this process is auxin. I discovered it was made by dying cells in plants, wood cells in particular. I published this hypothesis, but it didn't really catch on because most people thought something as important as a hormone must be synthesized by complex biochemical pathways. However, 50 years later, it turns out that all these attempts to explain it in terms of complex pathways have failed, and the dying cell hypothesis has recently risen to the fore again. I published a paper on it just a month ago in the Journal of Experimental Botany called The Production of Auxin by Dying Cells. You can see it on my website. And I also worked in Cambridge on the way in which auxin is transported in a polar direction from the leaf tips towards the roots. It only moves in one direction in what's called the polar auxin transport system. And that is a foundational study. It's now in all the botanical textbooks. It's a key feature of the way auxin works and plants develop. Well, this is what I was working on, and it became clear that these hypotheses were really victims of their own success. They explain auxin production, they explain auxin movement, but they explain it in all plants, in ferns, in pine trees, in palms, in bamboos, in roses, in foxgloves, in cabbages. And what's more, they explain it in the petals of the same plant and the leaves of the same plant. Hence, this can't explain why they're different, why the petals in the daffodil, in the cup, and the corolla are different from each other, why the leaf shapes of all the different species are different. You need some other explanation. And I got interested in the idea of morphogenetic fields, form-shaping fields, like invisible molds or blueprints for developing systems. An idea that had been proposed first in 1921 by Alexander Gurvich in Russia. And the idea of morphogenetic fields seemed to me the best way forward to understand form. But then there was the question of how are these fields inherited? Because genes don't explain form, they explain the inheritance of proteins and the control of protein synthesis. There had to be some other way they could be inherited, and I was completely stuck. For about 2 years, I just couldn't understand how these fields could work, because they were clearly inherited, they were historical. Biology is historical, it has history built into it. It's not just a reflection of Platonic ideal forms. The whole point of evolution is that it's historical. So I couldn't understand how this worked until a great new insight came to me, basically the idea of morphic resonance. And it came through reading a book of philosophy by Henri Bergson, the French philosopher. I read his book, Matter and Memory, not because of science, but because I was interested in Marcel Proust, the great novelist who'd been influenced by Bergson. And so I was reading it for literary reasons. But what Bergson shows there is that memory is probably not stored in the brain, and there's a form of causation that works directly across time. Now, it had never crossed my mind before that there could be causation that worked, as it were, at a distance in time. And as soon as I realized there could be a form of causation working across gaps in time, then the idea of the inheritance of morphogenetic fields by a new kind of causation working across time suddenly made sense of huge amounts of biology. Then I tried to think how it might work, and the idea of morphic resonance popped into my mind. I was in a state of extreme excitement for days, weeks, because more and more seemed to become clear. It didn't impress my colleagues in the biochemistry department at Cambridge, who, when I explained it to them, they were completely baffled by what I was trying to explain. So it didn't go over terribly well in the biochemistry department tea room. It went over a little bit better on High Table in Clare College, where some historians and philosophers were quite intrigued by the idea and quite supportive and helpful. But it soon became clear to me that if I published this, I'd have to think it through in much more detail. The biochemistry department in Cambridge wasn't the right place to do that. Everybody was busy working out enzyme mechanisms and structure of nucleic acids and so on. It just wasn't the right place for me. I wanted to work holistically with plants. And I'd been to India. I went there first in 1968, and the idea of working in agriculture in India suddenly became enormously appealing. I could work holistically. Agriculture is about holistic studies. You have to study whole plants in real fields with real weather and real diseases, and farmers who work under real economic conditions. Um, and I also wanted to do something useful. And as it happened, at that time, a new international institute was being set up in India, the International Crops Research Institute for the Semi-Arid Tropics, ICRISAT. And I was appointed principal plant physiologist. It was a fairly high prestige international institute. And it gave me a whole team to work with, a lab, fields on an experimental farm. I could do experiments all over India, and indeed I did some in the Middle East as well. I was working on chickpeas and pigeon peas. Um, I was running experiments in the Bekaa Valley in the Lebanon, for example. We had to abandon those because of machine gun damage, a problem we didn't encounter anywhere else. Um, but the working in ICRISAT was wonderful. I greatly enjoyed it. Being in India was wonderful. Um, and it gave me the space to go on thinking about morphic resonance. And I did this for another 5 years or so until I felt ready to write a book about it, to bring it together. I was helped when I was living in Hyderabad, where ICRISAT is, by a friendship with Helen Spurway, a great British biologist of a previous generation, who had gone out to India with her husband, J.B.S. Haldane. He died in India, but she'd inherited his library. And so a lot of the books I needed I could get from Haldane's library, at least those that hadn't been eaten by termites or gnawed by her jackal. She had a pet jackal. Um, and so I got to the point where I was ready to uh, write a book about this. And at that stage, I'd met Father Bede Griffiths, who lived in an ashram in Tamil Nadu in South India. He invited me to go and live in his ashram, a Benedictine ashram, uh, and write my book there, which I did. And I lived in total there for about 2 years. So I had a palm thatched hut under a palm tree on the bank of the sacred river Corvery. Um, and the ashram had quite a good library, of course, not scientific. I had to get books posted from the British Council Library in Bombay um, for the scientific work, or from friends in England. Um, but it was a perfect time for me to think about this, to write this book. I then went back to England, and with the book, which was called Towards a New Science of Life, and it was I submitted it to publishers, and it was rejected by 12 different publishers, one after another. They just they sent it to scientific uh, friends or colleagues, these publishers who were literary figures. At that time, there were hardly any publishers who knew anything about science. And their colleagues told them it would be controversial, so they backed off. Until I asked the only publisher I actually knew personally, Anthony Blond, who had a publishing firm called Blond and Briggs. And Anthony said, well, I'd love to do the book, Rupert, and here's a contract. So, he produced one a few days later and said, sign here. And I said, shouldn't I read it first? And he said, no, 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 it's pure formality. So after dinner and lots of wine, I signed this contract, signing over the world rights to this book for nothing to Blond. He later went bankrupt, and I got the rights back, fortunately. But one of his inputs, apart from the fact he published it, for which I was very grateful, was to change the titles. He said, no one reads books called Towards. He said, just cross it out. A New Science of Life. And I said, well, doesn't that sound a little bit immodest? He said, doesn't matter. He said, trust me, old boy. He said, I know about titles. He said, I told Schumacher to call his book Small is Beautiful. It worked. He said, so I know, well, okay. So anyway, Blond published the book and came out with a wonderful launch party by a friend of mine, now deceased, alas, Lindy Dufferin, on Midsummer's Day, or at least the summer solstice, June the 21st, 1981. And to start with, things went swimmingly well. There was a feature in New Scientist. Colin Tudge was immensely supportive and helpful. The Guardian wrote editorials. There were serious discussion in many scientific journals and magazines. But then, 3 months later, came this hammer blow, an editorial on the front page of Nature, the leading international scientific journal, called A Book for Burning. And I was denounced by the editor of Nature, Sir John Maddox, for heresy. And his aim was to run me out of town, to make sure I never got a job again or a grant in the scientific world. And he succeeded. I was unemployable from then on. And I became extremely dangerous to know. So Maddox succeeded, but and it did mean in terms of research on this hypothesis, I couldn't do it in regular universities because it was just too controversial. However, new doors opened, and when my book was published in America in 1982 by Jeremy Tarcher in Los Angeles, a whole new world opened up. California, I'd never been there before. I was invited by Stan Grof to teach in his program at Esalen. The Jungian societies in Los Angeles and San Francisco invited me to give talks, and I discovered a whole network of Jungian analysts and people influenced by Jung who were very well disposed towards my hypothesis. The folks at Claremont College, the process philosophy group at Claremont College in California, who studied the philosophy of Whitehead, were extremely sympathetic and helpful. I came to know David Bohm and Krishnamurti. We did dialogues together, as David mentioned, and David Bohm became an enormous help and support because from his way of thinking about quantum theory, morphic resonance made perfect sense. The idea that things could be connected through what he called the implicate order at a distance in time and space worked very well with his interpretation of quantum theory. I came to know other quantum theorists in Britain, in Germany, and elsewhere, in America and in Europe. And then New Scientist helped further. In 1982, a New Scientist ran an international competition for ideas for testing morphic resonance with a prize, a cash prize. And that led to a really creative set of ideas for tests. And they had to be simple tests because there was no funding for this research at the time. And there's never been very much. I mean, there's been a trickle of funding, but nothing on the scale of regular science. And so the idea was to come up with simple, inexpensive tests. And it was a very productive international brainstorming, and the winners were announced, and it really helped kickstart a new phase of research. Then in 1982, also, Robert L. Schwartz of the Tarrytown Center in New York, upstate New York, offered a Tarrytown Prize for the testing of morphic resonance and a $10,000 prize for the best test. He mentioned this to me. We were on the way to a party given by Michael Murphy, who founded the Esalen Institute. And I said, Bob, that would be a tremendous idea. And when we arrived, I told Michael Murphy about it, Bob Schwartz's offer of this prize. And Michael Murphy immediately got a glass and banged it with a spoon and called silence, said, "Folks," he said, "Bob Schwartz has just offered this $10,000 prize for a test of morphic resonance." And there were great cheers, and Schwartz was the hero of the evening. And I said to Michael afterwards, I said, "Why did you announce it so quickly? I'd only just told you." He said, "I didn't want Bob to go back on the idea." He said, "I thought I'd hold him to it." And indeed, it did hold him to it. And there was a $10,000 prize. There were some very, very good entries. The prize was won by Gary Schwartz, who many of you will know as a consciousness researcher, who was at that time a professor of psychology at Yale, who did an ingenious test involving Hebrew words. Then in 1987, the Institute of Noetic Sciences launched a contest for student projects to test morphic resonance. The results were announced in 1991, and again, there was a great creative outpouring of projects. And the first prize was won by Monica England, who was an undergraduate in psychology at Nottingham University in Britain, who did a test with crossword puzzles. Um, she got the Evening Standard crossword puzzle before it was published in the London Evening Standard, and tested people in Nottingham where you couldn't get the Evening Standard. It was a London paper, and in those days nothing was online. And she found, as predicted by morphic resonance, the crossword puzzle became easier to solve when tens of thousands of people had done it in London than it was the day before all these people had done it, as compared with the control crossword. So that was a very helpful intervention of the Institute of Noetic Sciences sponsoring this contest. It then turned out that the theory could be tested in a number of other realms. I hadn't initially thought of all these possible tests. And what I was concentrating on was trying to test the hypothesis empirically. I'm an experimental scientist, and the idea of testing it experimentally was what preoccupied me and still does. I was giving a seminar in the chemistry department at the University of Vermont when one of the professors raised the possibility that if morphic resonance is true, if it really happens, then the melting points of chemical compounds should increase over time, because morphic resonance should make the crystal structure more stable, and if it's more stable it should be harder to disrupt it, and how you disrupt it is by heating them up, and if it's harder to disrupt, you should be able to heat them to a higher temperature before they melted. So this idea led to the prediction that by morphic resonance the melting points of new compounds should rise. Those that have been around for thousands of years, that crystallize naturally, like salt crystals or asparagine on the leaves of plants, wouldn't show this effect because they've already had a backlog of millions of crystals. You wouldn't notice any difference against that background. But new compounds should show rise in melting points. So this was an outrageous prediction because melting points are called physical constants. You look them up in handbooks of physical constants. It says so on the cover, that they're constants. And so I started looking at melting points, and I found that actually they seem to go up for new compounds. I later worked with a retired chemist in British Columbia, Klaus Oehr, and Klaus did a much more exhaustive survey than I had done, and the results in the first slide show the melting points of compounds. You'll see the black line in the middle is the melting point given in the oldest reports that he could find in the chemical literature. Then you see the changes over time, over the next few decades of melting points, and you see the great majority of them have gone up. There's a few that went down. There could have been errors. I mean, you'd expect some errors. If they were random errors, you'd expect them to go up and down more or less equally. And probably the ones that seemed to go down might have been errors or measuring different versions of the compound, like hydrates as opposed to anhydrous crystals, something like that. But as you see, the great majority went up. And many of them went up, as you see, 5 degrees, 10, 20, 30, 40. Some of them went up 10, 20, 30, 40 degrees centigrade. We're not talking fractions of a degree here. I then did a series of studies of compounds that crystallize in nature compared with similar compounds that are human-made. The next slide shows the melting point of the compound salicin, which occurs in willow bark, and between 1902 and 1996, there was virtually no change in its melting point. If we look at the next slide, we see aspirin, first synthesized in the 19th century as a synthetic derivative of salicylic acid. And I didn't get the records in the 1890s, but between 1914 and 1996, the melting point had gone up by 8 degrees centigrade. and pressing back further, I'm sure we'd find a bigger increase. The next comparison shows cocaine, which occurs in coca leaves, the coca plant, and the natural form that crystallizes in coca leaves when they're dried hasn't shown any change in melting point over the 20th century. But cocaine hydrochloride, the next one, which is produced by extracting coca leaves with hydrochloric acid, the cocaine of commerce, shows a considerable increase from 184 to 196, 12 degrees centigrade over the 20th century. So here we see a series of data from chemicals, and it should be possible to do much more rigorous experiments with chemicals looking at melting points for looking for morphic resonance effects. I've tried to persuade chemists to do this. The closest I got was at Shell Industrial Chemical Laboratory here in Britain. But every time I've managed to persuade some chemists that it might be worth doing, it comes before the head of the lab or some committee or other, and then people say this is enormously controversial, we'll open a can of worms, we don't want it opened in our laboratory, and then I get this apologetic email. It's happened over and over again from the person I've been talking to saying, sorry, my boss has said we just can't do this. And so people are frightened. And so it would hardly cost anything to do some of these experiments. The barrier is not financial for some of these tests, but psychological and sociological. Well, now, the hypothesis can be tested in the realm of biology. I mention in my book some tests done with fruit flies by Mei-Wan Ho. The next slide shows a normal fruit fly at the top and a four-winged fruit fly at the bottom, which can come about as a result of mutation. It's called a homeotic mutant, where one organ is changed to another. The halteres, the balancing organs, are changed into an extra pair of wings. That can happen as a result of genetic mutation that switches the development from halteres to wings. I would say the morphogenetic field of the halteres is switched. It's like goes into an alternative, like flipping a channel on a TV set. Then the morphogenetic field of the wings takes over. Now, you can also produce this four-winged fly by exposing the eggs of fruit flies to ether soon after they're laid. This doesn't cause genetic changes, but it changes the development. It's a bit like thalidomide causing abnormal babies to develop. It's not a question of genetic change, but developmental disturbance. Now, experiments on this were done by Mei-Wan Ho and her colleagues at the Open University in England. And the next slide shows what they found. And in the first generation, which you see at the extreme left-hand corner, about 2% of the flies develop four wings in response to ether fumes, the eggs being exposed to ether fumes. In the next generation, it was about 6%. And it went on, after 11 generations, it was over 30%. If you stopped exposing them to ether, the dotted lines show that the percentage of four-winged flies fell off, but it continued. They continued to produce four-winged flies for quite a few generations, 5 generations or more. They were still producing some four-winged flies. This might now be called an epigenetic effect, something that changed the expression of the genes. But I think it's a mixture of morphic resonance and epigenetic effects. And the next slide shows what you would expect. On the top box, you see the untreated flies, then they're treated with ether, and those shaded boxes are ones which have been treated with ether. And normally in Ho's experiments, she bred from the ones treated with ether. So you don't know whether there's been an inheritable change through the inheritance of acquired characters, which has now been rebranded epigenetic inheritance, or whether it's morphic resonance. The lower line shows how you do the experiment to distinguish them. In each generation, you breed from flies that haven't been exposed to ether, but then some of them are exposed to ether, and you see how many develop four wings. And according to morphic resonance, the proportion developing four wings should increase, even though the ancestors have never been exposed to ether. And in the next slide, we show see what happens. Ho actually did an experiment rather like that, and in the first generation, 2% were changed, and then when she came back and did a second experiment, the first generation of the second experiment of untreated flies, it was 10%. The second generation, it was 6% originally, but when she did the experiment again, after a lot of flies had undergone this change, it was nearly 20%. That, I think, is a morphic resonance effect as opposed to an epigenetic effect. Now, one of the predictions of this hypothesis is that if you train rats to learn a new trick in one place, rats all around the world should learn it quicker. There's already evidence for this. I was challenged by skeptical British scientist Stephen Rose at the Open University to test what he called my seemingly absurd hypothesis in his laboratory under his control. Some of my friends said, "You'd be foolish to let Rose, who's such an extremely intemperate and also hostile critic, to be in charge of this research." But I thought, okay, well, no one else has offered me a chance to test it, so I'll take what I'm offered. And so I accepted his challenge. We did an experiment with day-old chicks. They were exposed to a yellow LED light, and they were made sick soon after they pecked at it. And that meant that thereafter they no longer pecked at yellow lights. But there was a control stimulus that they went on pecking at. My prediction was that relative to the control, generation after generation, fresh batches of chicks should show more hesitancy, a greater latency before pecking at the yellow bead. And the results in the next slide showed there was exactly that effect. The latency increased over these generations. They weren't descended from the previous chicks, it was just a fresh batch. This was a significant effect. Well, Rose immediately denounced this result as being an artifact of some kind and said it couldn't possibly be morphic resonance. But the fact is, it showed the effect and it worked as predicted. And that made it very clear to me, if I needed further evidence, that people who are opposed to something don't just say, when you present them with the evidence, in this case from his own lab, they don't say, okay, yes, it really is happening. They say there's something terribly wrong with this evidence. And anyway, he did say that, and I then refuted what he said, and the dispute took place in scientific journals, and you can read about it if you're interested in the details. I also did a series of tests on television, and the next slide shows a puzzle picture. And oh, sorry, I mentioned there's one further slide here. This shows the rise in IQ, average IQ, over generations from 1918 to 1989, so-called Flynn effect. I predicted that there would be a rise in average IQ, not because people are getting smarter, but because the tests are getting easier because so many have done them. And this effect is now well known, and this shows the effect of 30% rise in the US IQ. No evidence that people have got 30% smarter. The tests have just got easier to do. And the next slide shows a puzzle picture. And I did a series of experiments on British television with puzzle pictures. This puzzle picture has a hidden image. And once you've seen the answer, you just get it. And the idea was, when people have been shown the answer to a puzzle picture on British television, do people in Germany and elsewhere in Europe recognize it more easily compared with a control puzzle picture? And let me show the answer now. And it's a cowboy on a horse. And if we now go back to the initial image, you should get it straight away. It's a very rapid form of learning. And it turned out people did get, it did get easier for people to recognize the puzzle picture in Germany after people had been shown it in Britain. Now, the research has been going on in a variety of ways which sheds further light on morphic resonance, and one of these experiments was done by a French scientist, Miroslav Hill, who wasn't looking for morphic resonance effects, but was looking at the ability of cells grown in tissue culture, mammalian cells, to respond to toxins to overcome toxic stresses or heat stresses. And the next slide shows what he did in his experiments. In each experiment, he subcultured cells and put some of them into the normal medium without toxin. The white circles represent each generation of the cells were subcultured, but some of them were put in a toxic medium. And after a few generations, the cells in the toxic medium began to thrive. They began to survive and divide and grow. And after that, all the cells in the toxic medium, or at least many of them, were able to survive, whereas previously they hadn't. Now, his explanation, which in the next slide we see, was that the top diagram represents Hill's explanation that somehow the cells that had developed the resistance influenced the untreated cells so that when they were treated in the next generation, they had this resistance. But he had to postulate that they did this through some kind of quantum entanglement. There was no physical contact, for which there's no evidence in cellular cultures. My interpretation, you see below, is that the ones who developed resistance could pass this on by morphic resonance. The dotted lines, the curved dotted lines at the top, would mean that subsequent cells exposed to this toxin would be able to resist it better because the morphic resonance from previous ones exposed to the toxin. Now, this type of experiment should be relatively easy to carry out with microbes, with yeasts, or with cells in tissue culture. And if any of you have labs where you're able to do this, do please get in touch with me. You can contact me through my website, because this would be a very productive way of testing for morphic resonance in biology. It just requires someone who's open-minded with a lab and time to do this. The actual cost of materials is very small. Okay, well now, in the new edition of A New Science of Life, it's now in its third edition, I outlined 10 further tests for morphic resonance. One of them is in the realm of low temperature physics, Bose-Einstein condensates, where matter behaves strangely. It has become superconductive, superfluid, there's no electrical resistance. The whole system behaves as a single quantum particle, even though it's made up of millions of atoms. And this only happens at low temperatures. The background temperature of the universe is 2.7 degrees above absolute zero. In low temperature physics labs, people can get down to 0.1 degree above absolute zero or even less. And anything that's done at that temperature would be new in the history of the universe, because unless there are low temperature physics labs on other planets, these would happen for the first time. And therefore one could do morphic resonance experiments in low temperature physics labs. If a Bose-Einstein condensate takes a certain amount of time to appear, if you keep making it, the same compound at the same temperature, it should appear more quickly as time goes on, as a new habit builds up. Anyway, there are 10 new tests I put forward in A New Science of Life in the appendix. So if you're interested, take a look. And if you have a lab, and these are tests in physics, chemistry, biology, psychology, and analog computing, do please get in touch, because what I most keenly want is for these tests to happen. Now, there's also been advances in the study of vibratory systems, and the next slide shows some results from some experiments I did with my son Merlin, who wrote a book on fungi called Entangled Life. We have a laboratory at home, and we've been doing experiments with vibrating fluids. These are water vibrated at different frequencies. And as you see, there are all these patterns appear. Just add vibration. Um, and these different frequencies produce these complex patterns, and there's a whole range more. We've published a paper on this in Water Journal. And I think that natural systems are vibratory. Brains certainly are, and I think developing tissues are. And I think recent research on vibration feeds into an understanding of morphic resonance through giving us a better understanding of vibratory fields. The next slide shows a model, a computer model of vibratory modes in the electromagnetic field of leaves. These simulations are due to a researcher called Piertak, and she, as you see, showed that you can get patterning effects of vibration, and so a lot of modern developmental biology is still based on the idea of clunky chemical gradients. You just don't need them. I think leaves and other developing systems have electromagnetic fields which have resonant patterns, and I think the morphic resonance works through those electromagnetic patterns. Morphic resonance also applies to the organization of groups of animals. And the next slide shows flocks of starlings, a murmuration of starlings over Brighton West Pier. And the next slide shows other pictures of starlings as they move in these flocks. It's like a field phenomenon. The birds not only know where their neighbors are, but where they're going to move to, otherwise they'd collide, and they don't collide. And the next slide shows a school of fish where you have very similar phenomenon. I think that social groups of animals have fields, morphic fields, fields of social groups. They're the social equivalent of morphogenetic fields. The generic name for these fields is morphic fields with morphic resonance, a kind of memory in the group field. And I think that similar fields affect human groups, including human families. And we can finish that slide now. This again is an area where morphic resonance has taken on a whole new dimension through the work on family constellations therapy. Many of you will have heard of this, where the therapist treats the whole family as a field. The members of the family are within an interrelated field. And these family fields often seem to inherit patterns from past generations, which can sometimes be very destructive. If a member of in a past generation committed suicide or was expelled from the family or committed some terrible crime or for some other reason was excluded, then in the present generation, a member of the family follows them, as it were, and excludes themselves or becomes suicidal in ways that individual psychotherapy can't address. But this form of family constellation therapy is very, very effective. I've had many opportunities to watch it in action because my wife, Jill Peirce, does wonderful family constellation sessions, which she's now doing on Zoom. And I've seen through Jill's work and through the work of Bert Hellinger, the German proponent of this, who was one of the main people to popularize this system of therapy. I've seen many examples of transformative effects that seem to me to show field effects with non-local effects on different members of the family. People can be miles away from someone doing this therapy, and yet it can affect them. Well, in conclusion, I just want to say that the problems within mainstream science have continued to pile up. I address these in my book, The Science Delusion, called Science Set Free in the United States. And many of these problems can be resolved if we take into account morphic resonance. In cosmology, for example, there's a big debate about whether this universe at the moment of the Big Bang had all the constants and laws of nature fixed exactly right for life as we know it. Um, was there a fine tuning of all these laws of nature? Um, a lot of scientists are atheists and they hate the idea of some kind of mechanical God fine tuning the world machine. It's a very crude idea of God. Most Christians and most believers in God would not think of God as an engineer outside the universe fine tuning it. But anyway, to avoid any hint of God, they prefer to say there must be billions, trillions of actual universes, of which ours is the only one which is suitable for us to be aware of it in, the only one we can exist in. But all the others actually exist, so you don't need God. Um, well, this debate, the multiverse universe debate, both sides assume that all the laws of nature were fixed at the moment of the Big Bang and all the constants were fixed. Well, as I've shown, the constants may vary. I discussed this in the science delusion. Um, but also the laws don't have to be fixed. If the laws are like habits, they can evolve along with nature. They don't all have to be exactly fixed at the moment of the Big Bang. The whole of this debate just dissolves away like the morning mist if we have a view of the evolution of the habits of nature. Then cosmologists have had to postulate dark matter to explain galaxies, which they assume are held together by gravitation. And the known amounts of matter don't explain the structure of the galaxy. So they then assume there's invisible dark matter, uh, which is titrated into their equations of galaxies in just the right amount to explain the facts. The only problem is that no one knows what dark matter is, and there's no evidence that it actually exists at all. And yet there's supposed to be about 5 times more dark matter than real matter of the kind we already know. But if the galaxy is an organism, if the stars within it are like cells within an organism, we don't have to say it's just gravity that holds it together. Um, in my article on Is the Sun Conscious, I discuss the hypothesis of Greg Matloff, who proposes that stars actually move like cells do in embryos to take up the right position. He calls it the volitional star hypothesis. And if we think of the uh, galaxy as an organism, then we don't need all this dark matter. We can have a much more organic view of astronomy and indeed of the entire cosmos. Then morphic resonance helps understand very puzzling data about inheritance. It turns out genes, as a result of the Genome Project, we now know that genes don't explain more than about 10% of inheritance, even of common things like height or proneness to diseases or proneness to schizophrenia. And the amount of inheritance they don't explain is something like 80 or 90% of what's inherited. And this is called the missing heritability problem within biology. And I think the reason that there's a missing heritability problem is that the genes don't explain form, instinct, behavior. Um, they only explain the inheritance of the structure of proteins, which is what we know genes do. So morphic resonance together with epigenetic inheritance, I think, can enable us to reinterpret inheritance and indeed the entire evolutionary process, which depends on inheritance, in what is now called the extended evolutionary synthesis, which is taking over from the narrow, rather shrill, dogmatic neo-Darwinism that's been so widely popularized by Richard Dawkins and his colleagues. And then attempts to locate memories in brains have failed over and over again, and recent attempts to track down the so-called engram, the memory trace, again have run into problems, as they always do, over and over again for more than 100 years. And I think this is because the memories aren't in the brains in the first place. So morphic fields also enable us to think in terms of extended minds. I don't have time to discuss that. I'm giving a seminar next weekend on the extended minds of animals and how they connect with ours, called The Unexplained Powers of Animals. And the whole new range of ways of thinking about consciousness open up. So this is a very much an ongoing project, and um, if you're interested in finding out more, then do take a look at my books. And the next slide shows um, A New Science of Life in the UK edition. This is the third edition, fully updated. Um, and in the US, it's been retitled, next slide, um, Morphic Resonance. It's the same book. Don't buy both. You're thinking you'll get more. You won't. You'll get the same book with a different title. And this was my first book, as we met this evening to discuss, um, and is brief and somewhat technical. My main theoretical book on morphic resonance, which deals with memory, psychology, cultural inheritance, rituals, the role of morphic resonance in religious rituals, and many other topics, is called The Presence of the Past. And this is the new edition in Britain, and the US new edition, both of these fully updated, looks like that. It's the same book. It's just those are just different editions in Britain and America. So if you're interested in going into more detail, do please take a look at these books. And right now, I think we've got some time for questions, if any of you would like to ask more about this.
Thank you so much, Rupert. Well, that was a sort of tour de force, of the tour d'horizon, as the French would say, giving us an idea of the, as it were, the epigenetic development of morphic resonance over the last 40 years, and what still needs to be tested. And indeed, at the end, you were talking about the puzzles that are illuminated by the hypothesis, and these which could potentially be an angle of approach in a number of disciplines. And so I think that's very exciting. And we really need orthodox scientists to spread their wings a bit and to be a little more adventurous and less fearful for their narrow reputations. And I just I've got some very interesting questions to put to you, but I wondered if, I know that Lewis Wolpert died recently, and he was one of your, the person you actually had a debate with him, which I attended at the Royal Society of Arts. But you had a bet, didn't you, of a case of fine port, and I remember advising you on what port to get. How's that going in terms of, can you remind us of what the debate was, what the issue was, and where do you think it's got to?
Well, in 2009, Lewis Wolpert and I had a debate at Cambridge University, and the last event in the Cambridge University Science Festival. It was on the nature of life. And Wolpert, in this debate, said that it would soon be possible to predict every detail of a new organism based on the genetic code in its fertilized egg and modify it at will. And so that genetics could predict everything about organisms. And I challenged him on that. I said, I don't think that's at all true, Lewis, and I don't think it's going to happen. And I said, I bet you a bottle of champagne it won't happen within 10 years. He said, well, maybe not 10 years, maybe 20. I said, okay, a bottle of champagne in 20 years. And he said, well, no, I said, that might be a bit more complicated. No, well, perhaps 100 years. And I said, you said soon. And I said, both of us will be dead in 100 years' time. This is promissory materialism in its most extreme form. Anyway, I followed up afterwards and I said, Lewis, can we have a debate, a bet that's feasible within our lifetimes, or potential lifetimes, 20 years is, and so he said, all right. I said, you've said humans are too difficult. What about a mouse? He said, all right, 20 years, predict every detail of a mouse. Then we agreed on it. We agreed on the stake, the case of Quinto de Vesuvio 2005, thanks to your advice, David. We paid half each. And there it is, this case of fine port is in the vaults of the Wine Society, awaiting 2029 when the bet terminates. So the New Scientist were going to publish the bet. But he got onto me, he said, Rupert, I just can't, chicks, mouse is a bit too different, have to be a chick. Anyway, after several iterations, we got down to a nematode worm. Um, and so I said, okay, any multicellular organism. And we published the bet. Um, and last year, the 10th anniversary, no, 2019, the 10th anniversary, a betting company called FitzDares opened a book so that anyone who wants to can bet on whether Walpole or I will win this bet in 2029. Um, anyway, it looks extremely unlikely that he or his heirs will. Well, he won't win it, but his heir, he has a son who's a fellow at Trinity College, Cambridge. He's got a scientific son who will no doubt be able to watch out for the Walpert interest in the case. And so anyway, that's where the status of that bet. And I think that if you took a bet among biologists today, the vast majority would think that Walpert's going to lose.
Ah, interesting. Very interesting. So there's a sort of personal but very interesting question. One of the first ones from John Brown. He said, could morphic resonance be a vehicle of predetermined information? And he said that ancient myths has the birds as the harbingers of the knowledge of death. On 3 separate occasions, I personally experienced this. In all 3 separate incidents, a bird appeared inside my house, all on a Friday. In 1 week on the following Fridays, and spaced a few years apart. First my son, second my sister, third my wife. All died in exactly the same kind of accidents. In addition, my wife and sister had exact first and last names and were exactly the same age.
Gosh. Well, I think these, I mean, I've heard many stories of this kind of presaging of death. And it's very, very hard to understand these. I mean, it would be, apart from anything else, you can't exactly do experiments on it. You know, you can't sort of have people die at randomized times to make sure to see whether birds appear a week before. So it's one of those mysteries which I think the most we can do is document them. And to explain it in terms of morphic resonance would be difficult. Morphic resonance is about habits of nature, and perhaps it's a habit for birds to announce deaths in certain families. It seems to be. But how do the birds know? And this is going way beyond the scope of this hypothesis. I mean, there are many mysteries which this hypothesis doesn't embrace. I mean, it might hint towards a possible answer. But I myself focus primarily on the regularities of things that are easier to test. This would take us into those very intriguing realms where we can only say we just don't know and we just don't
I
understand.
think that's a good answer. Then there's one more related to the current situation. Do you think there's any relationship between morphic resonance and herd immunity?
Well, I've thought quite a bit about this. The thing is that morphic resonance would mean, or might mean, that when you have a lot of people recover from a disease, that the response, the antibody response to that disease, might become easier for others to have the same kind of response. In other words, immune responses might be subject to morphic resonance, and the more people that get better from a disease, the easier it may be for others to get better from it. And it's interesting that about a third of the people who are infected with COVID now, at least in Britain, have no symptoms at all. Their antibody response is so effective that you wouldn't know they had it unless you did actual COVID tests. So it's possible that's happening. On the other hand, it can't be true of all diseases, otherwise all diseases would die out. And diseases in the flu and cold family, these viral respiratory diseases, do die out or tend to die out. But there are other diseases like smallpox and so on that have only died out as a result of eradication campaigns with vaccination. So if morphic resonance plays a part, then one would have to find out why does it work more for some diseases than others. This would be a whole realm of exploration in epidemiology. I mean, as soon as you start thinking in terms of morphic resonance, new questions come up everywhere and potential new scientific experiments and lines of inquiry.
Yes, thank you. There's a couple of questions about how morphic resonance relates to the holographic universe and also connection with quantum entanglement. I think the quantum entanglement you've already addressed through what you said about David Bohm. But do you want to comment at all on holographic universe? We had Carl Pribram at a Mystics and Scientists around the same time, and I'm sure you knew him.
Yes, I did. Indeed, I met my wife Jill through Carl Pribram. We were at a conference in Bombay in 1982, and I was talking to Carl Pribram, arguing about the nature of memory, when Jill came up and he introduced us because he knew Jill. So I have Carl Pribram to thank for introducing me to my wife. Well, Pribram at first thought memory was stored in the brain. Then he thought, because you couldn't find localized memory traces, that it would be stored holographically over large regions of the brain. Then he got interested in David Bohm's ideas and then thought it might be stored holographically in the whole universe. You know that the holograms have a distributed pattern of storage, and the whole is present in each part. And so in a sense, morphic resonance is saying that. It's saying that the whole of all the information in the universe is potentially present everywhere from the past. There's a kind of entanglement, if you like, but it's not the same as quantum entanglement as we usually think of it, which is simultaneous in space, whereas this involves a connection from the past across time, and that goes beyond current quantum theory. David Bohm thought current quantum theory needed extending or expanding, but you wouldn't get many conventional quantum theorists who would think of morphic resonance as fitting within quantum theory as currently understood. So the holographic universe is a kind of metaphor of the way that the whole can be present in each part. A hologram is in itself is static. It's a kind of photograph. So it doesn't have the time dimension. So all metaphors are inadequate, but what it's trying to show is that the information is present everywhere. And in morphic resonance and in David Bohm's idea of the implicate order, that's what we're saying, that the information is potentially present everywhere.
Yes. Do you think, I'm not sure how this question angles in, but do you think that morphic fields will ever be detectable in any way? Is that really a
Well,
question?
all the experiments that I propose for morphic resonance are ways of detecting the fields. If you train rats to learn a new trick in London and rats learn it quicker in Paris and New York, that's detecting a morphic field. When people ask this question, they usually think you get some kind of meter that detects,
Yes.
like a damp
Yeah.
meter or
Yeah.
an ammeter. But the fact is that meters that detect things, usually people think in terms of electric meters. Well, electric meters detect electric phenomena. Magnetometers detect magnetic phenomena. You don't detect a gravitational field with an electric meter or a magnetometer. You only detect fields of the appropriate kind.
Mm.
So to detect a morphic field, you'd need a morphic measuring system, which is the kinds of experiments I've been proposing. You wouldn't necessarily expect to see it or to detect it. It might interact. I think they do interact with electromagnetic fields. And it's possible that some kinds of Kirlian photography, where you see a kind of aura around leaves, may be ways of visualizing these fields. But there are many artifacts in Kirlian photography caused by damp and humidity, and the research on it has been not very rigorous, and so it's very hard to know. I would say it's an open question as to whether you can detect them through um, electrical means. But all the experiments for testing for morphic resonance are ways of testing morphic fields ultimately.
Yes, exactly. Thank you. Interesting question here. Could the morphic field be the result of the mind acting in matter or in a metadata that forms even the laws of nature, since consciousness is an intimate element or part of the fabric of our reality, as proposed by Sir Roger Penrose? I think in a
Well,
sense what you're saying, isn't it?
well, not exactly. I mean, this is a really tricky question because morphic resonance is really about habits. The subtitle of my book, The Presence of the Past, is Morphic Resonance and the Habits of Nature. And habits are unconscious. Our own habits are largely unconscious. And I think that the instincts of animals are largely unconscious, and the habits of plants when they grow their leaves and things are largely unconscious, and probably the habits of galaxies might be unconscious too. So most habits are unconscious. Um, where consciousness comes in is where there has to be a choice among possibilities, and it's to do with freedom. And I follow Whitehead in this way of thinking about it. Um, and what I haven't discussed this evening, owing to the limited time, is creativity. Evolution has to involve more than simply habits, otherwise, things would just repeat. And you can sometimes have habits spreading, like in parallel or convergent evolution. A habit that develops in one part of the world, like being a mammal, like a mouse, for example, could spread to another part of the world, like Australia, where you can have a marsupial mouse. You could have parallel evolution or parallel evolution of the eye. Um, and that could be habits spreading. But then you've still got the question of how do you get the mouse in the first place or an eye in the first place? And morphic resonance doesn't explain creativity. It only explains how once new things have happened, through repetition they become habitual. And consciousness plays a part in creativity. Um, but it's, again, even when we come to that, it's not immediately obvious. We humans are often creative, and new science, new arts, new music happening all the time. But when you ask a creative person where it came from, they often don't know. They just say it came to me in a flash, or I suddenly realized, or I dreamt of it, or something like that. So how does it come into our own minds? We don't even understand creativity in the human realm. So when we come to the whole cosmic realm, there clearly is a creative influence working through all nature, interacting with the habits of nature. Um, but the way you think of it really depends on your bigger picture, metaphysical or religious or theological or philosophical view of the larger picture of reality. But once something's happened and been repeated, then morphic resonance can take over and help it to be repeated more and more.
One of the attendees has pointed out that we can hear the birds coming from your garden, through the Zoom, which is rather nice. And this leads into the next question: is can morphic resonance help us rescue the ecosphere? Does increased concern for our planet make it easier for others to become concerned, or more likely they'll become concerned? So could morphic resonance be triggered or amplified by mainstream media suggesting planetary care is likely?
Well, I think morphic resonance plays a part in the spirit of the times, what the Germans call the Zeitgeist. That it influences our thinking and our attitudes. It's not, however, compulsory. Morphic resonance doesn't have a built-in moral filter, and it means that things that become habitual and when more people do them, they become easier for others to adopt. The fastest spreading habits in the world at the moment are those of consumerism, which Western capitalist culture has now converted billions of people all over the world into being consumerists who look at advertising and want things they might not otherwise have wanted. So consumerism is unfortunately a very fast spreading habit in China, in India, in Africa, and in many other parts of the world. And of course, it's long been a dominant feature of our own societies. Um, but I think also that the awareness of environmental problems will be amplified by and made easier for people to get through morphic resonance. And although there's no moral filter in morphic resonance itself, it does mean we're a bit more responsible than we might otherwise be, not only for our actions and our words, but also for our thoughts and attitudes, because those are likely to spread by morphic resonance, making it easier for others to adopt the same attitude or way of thinking.
Yes, and I wonder whether that this also applies to coming out, which we've talked about in coming out in this in a scientific and philosophical sense, because a lot of scientists, and we did this survey a few years ago, you remember, have interesting paranormal, psychic, spiritual experiences, but they don't want to admit that to their colleagues because they're afraid that they're going to lose their reputation, even though the very same colleagues they're afraid of are in exactly the same situation. So I wonder if we could somehow use morphic resonance as a way of helping people pluck up the courage to be true to themselves.
Well, I think it would happen automatically if the more people who come out of these closet holists who are present in most scientific and medical and engineering institutions, um, the more that people do come out, the more it will empower and help others and make it easier for them to accept that you can actually survive. And like gay people now, they've come out of the closet, many of them, and it's become much more socially acceptable. Um, and I think that holistic ideas in science will become more acceptable as more people identify with them in public. And so, yes, morphic resonance might help that process, but it's something that um, all of us, the Institute of Noetic Sciences and the Scientific and Medical Network, are probably the two main catalysts for coming out in the Western world. And I remember when I first joined, became part of these organizations, they were really quite small and fringe. Um, and now the number of members is increasing. It's becoming much more mainstream. Consciousness research, which Noetic Sciences has promoted for nearly 50 years, is now a major topic in many universities. And the more holistic approach to science and medicine that the scientific and medical networks promoted is becoming increasingly important. So I think that these organizations that we're part of have a very valuable role to play in actually catalyzing this process and have been doing that um, increasingly effectively over the years.
Yes, thank you, Rupert. Final question that we've got time to take, and I'm sorry we obviously got through 123 questions here, so we can look at them sort of at our leisure. This is from Alan Mulby on cathedrals. It's very much up your street. Places of worship seem to have a tangible atmosphere, sense of stillness and peace. Could this be due to morphic resonance? And he's asking whether one could do experiments with blindfolded individuals entering different buildings to show the effect. I'm not sure about that, but any thoughts on that? You might
Well,
say something. Your choral evensong initiative.
well, yes. The thing is that there's a memory when we go to places. Say you enter a cathedral or a temple or a mosque or some sacred cave or a sacred grove or something like that, a holy place. Um, when you go there, the sensory stimuli that impinge on your eyes and ears and nose and so on are similar to those that other people have experienced there. And that will put us in morphic resonance with those who've been there before. So there'll be a kind of memory of the place. I'm not suggesting that it's actually etched into the stones of the temple or the cathedral. I'm suggesting we resonate with other people who've been there and had experiences, often of a mystical experience or of a revelatory experience or a sense of connection, some kind of spiritual experience. Now, there are places also with very bad memories, and most stories you hear of haunted houses usually tell of some awful thing that's happened there. So there can be negative memories too. Again, it's not all good. But I think that holy places, which become a focus of pilgrimage, um, do have this kind of memory and quality. And I'm one of the people who helped set up the British Pilgrimage Trust, which is reopening the ancient footpath pilgrimage routes to the old holy places of Britain. And the British Pilgrimage Trust has a website which you can call britishpilgrimage.org. And one of the best ways of visiting a cathedral in England is to walk there on paths through the countryside. The routes are given on the British Pilgrimage website. And time your arrival, say you arrive in the evening, and English cathedrals have a wonderful choral service in the evening every day in many cathedrals, weekdays as well as Sundays, called choral evensong, sung by very well-trained choirs. And free of charge, you can enter this enchanted world, literally enchanted, as the whole cathedral echoes to sacred chant. And it's one of the most uplifting experiences I know in Britain, and strongly recommend. There's a website called choralevensong.org, CHORAL, EVENSONG.org, where you can find out where these services are happening. And now, because many of them are doing them streamed on Zoom or Facebook, anywhere in the world, you can actually attend these services virtually by going to this website and go to recordings or live streamed services. So tapping into these traditions and memories is actually open to everybody, and it's free. It doesn't require you to sign up to any particular belief system. Indeed, the British Pilgrimage Trust, when it has organised pilgrimages, has as its slogan, "Bring your own beliefs." So yes, this question of memories in places, I think, is very important. There's another aspect of life which I think morphic resonance can help to illuminate.
Thank you, Rupert. You missed out a very important element here, which is the research on cream tea, which you should have before you go to Evensong. And I know you're aficionado of cream teas. We won't say any more about that.
Well, except for Americans who may not know what a cream tea is. Here in England, there's a tradition. You have a tea with scones or scones, and instead of butter, clotted cream and things like strawberry jam. It's, I'm afraid, not a low keto diet, but as an occasional treat, very good. And most cathedrals have tea rooms where you can have a cream tea before choral evensong. So that's part of the experience, at least for some of us.
Yes, thank you, Rupert. We'll put these in the recording email. There are all the references to the various initiatives. Any closing thoughts?
Well, I'm just very, very pleased that we've reached this 40th anniversary and that things are opening up. You know, almost every day that passes, I feel that at last the sciences are moving in the right direction, and there's a greater sense of openness within the scientific world. And so I suppose my closing thoughts are that I'm actually, despite all the gloom in the world, quite optimistic about the transformation in science, paradigm shift that all of us, probably all the people on this Zoom call, have been thinking about for years, is actually happening. And I think we need to prepare ourselves for a whole new world in which the educational system needs to reflect this more holistic attitude. The science funding system needs to reflect it. And of course, it needs to play in urgently to our need to adapt to living more sustainably on the Earth. The mechanistic, mechanical worldview is the worst possible worldview for living sustainably on the Earth. A more holistic worldview, of which morphic resonance is part, seems to me not only true, but essential for our survival.